So today we are going to graph systems of linear inequalities. It's just like graphing inequalities, except we're going to graph two of them and shade twice, and where they overlap is going to be your final answer. So first off, I'm going to graph number 1. I'm going to graph this 2x plus 3 by going to a positive 3 and then up 2 over 1. Keep doing that. And then to get more points down here, I'm going to go down 2 and left 1. Okay, so now we need to see if it is solid or dashed, and since this doesn't have an equal to sign underneath it, it's going to be dashed. So draw your best dashed line. Okay, so now I need to either shade above or below, and since that's less than, I'm going to shade below. So I'm going to take a highlighter, let's do pink, and I'm going to shade everything below this line right here. Oh, that didn't work. Okay, so shade everything down here. Okay, so now I'm going to graph this other line right here in blue. So I'm going to start at a positive 2. So a little right underneath that. Then I'm going to go down 3 over 1. I'm going to keep doing that. Okay, so now I'm going to go up 3 over 1, 1, 2, 3 over 1. Alright, so now I need to see if it is solid or dashed, and since there's an equal to, it's a solid line. Okay, so now I need to decide if I need to shade above or below this blue line, and since it's greater than, I need to shade above this blue line. So let me take another highlighter, let's say yellow, and shade above this. And I am going to have some overlap right here. So I'm going to shade everything above this blue line. Okay, so now with inequalities in systems, you're looking for the overlap. So I'm basically looking where this purple and this yellow overlap, and you'll notice it turned red. So this right here is my solution. Okay, everything in red, and it can even be on this line since it was solid, but it can't be any of those points on that line since they were dashed. So if you want with your pencil, I would maybe draw horizontal lines like this, and then vertical lines like this, and then how you can see your solution is when they're overlapping, okay? So why don't you try this one over here, so press pause, or listen to me. So I'm going to go to positive 3, and then up 1 over 1. Then go down 1 and left 1. Okay. Now it needs to be solid, so let me fill in that line. Okay, so now let me graph this other line by going to a positive 8 and down 3 over 2. Oh, I forgot to shade. Okay. With this blue line, I need to go less than, so I need to shade everything below here. So let's maybe shade this way. Okay. Now to graph the other line, I'll graph it in red. So go to a positive 8, down 3 over 2. Okay, so now that you have that line, which that looks off. Hold on. Messed up right there. Okay. So now that we have that line, is it going to be solid or dashed? So it's going to be dashed. Now I need to look at this red line and see if I need to go above or below. And so greater than means I need to go above. So I need to shade everything above. So I'm going to do it this kind of way. Okay? So you can see I've got this blue section down here, I have a red section up here, and I have a blue and red right here. So this area right here is my solution set. So let me kind of darken that in. Everything right here is my solution. Okay? Alright, let's look at these problems down here. These are not necessarily any harder. You just have to change them to y equals. So let me subtract x. I would have y is greater than negative x minus 2. And that's an imaginary 1 over 1. So let me go ahead and graph that line, and you will shade below it. So go to a negative 2, and go down 1 over 1, and keep doing that. Go up and left. Alright, so that does need to be dashed, so I'm just going to leave it like that. But this is a greater than sign, so I'm going to shade above. Alright, now let me change this problem over here by adding 3x. So you'd have y is less than or equal to 3x plus a 6. So I'm going to graph it a 6. I would go up 3 and over 1, down 3 and left 1. Alright, that line needs to be solid. And then you are going to shade below that line. And so here is everything below that line. So this right here, this blue and red area is going to be your solution. So everything right there. Okay? Let's look at number 4. I'm going to, again, put it in y equals mx plus b. So let me rewrite that problem right here. So negative 5y is less than or equal to negative 3x minus a 10. Divide by a negative 5. Make sure you flip your sign. Positive 3 over 5x plus a 2. So let's graph that line by going to a positive 2 and up 3 over 5. Also go down 3. Alright, so that needs to be solid. And I'm going to shade greater than. So I'm actually going to shade all of this up here. Okay. So now let's change this equation down here. So I would have 3x minus 5y is less than 40 minus 3x. Negative 5y is less than negative 3x plus 40. Divide by negative 5 on all of those, and you would have to change your sign and get positive 3/5 x minus 8. So notice those have the same slope, but we're not going to write no solution on them yet because we have to graph them. So start at the negative 8 and go up 3 over 5. Up 3 over 5, and that's going to be a dashed line. Okay, but now I need to shade, so let's look at this. I need to shade above my green line, so everything above my green line. Okay, so notice where they overlap is actually just in this area up here. So this right here would be my solution area. Okay, so if you want to darken that in maybe another color, or make sure I know that it is overlapping. So here are some examples. These are going to be either horizontal or vertical lines. Remember, if it's x equals a number, that's going to be an up and down line, and if it's y equals a number, that's going to be a horizontal line through that number. So let me graph this. Let me graph x is greater than or equal to a -2. So here is -2 on the x, up and down line through it, and it should be solid. So then if you see this graph is pointing to the right, so I'm going to shade everything to the right. Alright, with my blue pen, I'm going to graph y is less than a 3, so I'm going to go to a 3 on the y. It's going to be a horizontal line. Should be dashed, so let me erase that. Okay, and it says less than, so I'm going to shade everything below it. So if you'll notice, I have a blank area, a blue area, a green area up top, and I have a blue and green right here, so every number in here would be a solution. Okay. Now remember, if this is dashed, that means I can't pick any point on this line to be a solution, but I can pick any point on this line. So it says right here, determine whether it is not, whether the points lie in the solution set. So 1, 1 would be 1, 1 right there. So yes, that point does lie in my solution set. -3, 2, -1, 2, 3, +2. This right here is not going to lie in my solution set because it's not in this color over here. Then let's try -2, 3, -2, 1, 2, 3. Now this one is hard because it lies on the solid line, but it also lies on the dashed line. So if it lies on the dashed line, that means it cannot be a solution. Okay? Alright, let's try the last problem. Alright, I need to graph these right here. So why don't you take a chance? I'm going to press pause and you graph those two. Alright, so if you are joining me, you just changed this equation over here into y equals mx plus b. Since your y was negative, make sure you flipped your sign. And so we're going to graph this. So I'm going to go to -3. And that's really hard to see, so I'm going to redraw this. Okay, so I'm going to go to a, hello Bill, -3. And I'm going to go up 3 over 2, up 3 over 2, up 3 over 2, down 3, left 2. So that needs to be a dashed line. Alright, shade below it. Alright, now I need to shade y is less than or greater than or equal to a 4. So go to a 4 on the y, draw a solid line, and shade above it. Okay? So what you'll notice is there's this tiny, 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 tiny area up here, and that's my solution. Okay? So a point that would lie in it would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So we'll say 7, 5 lies in it. It says state one point that does not lie in A, so you can literally pick any point that you see over here that is not in one of these points. Okay? If you will turn it on the back, here's some kind of multiple choice answers that you could see on your EOC. And they're going to be mean, and they're going to give them to you all in standard form. But you can look at this graph and see that they're both dashed. So you can eliminate A because that has an equal to sign. You can also eliminate B because that has an equal to sign as well. So luckily you only have to change 2 of these. So let's look at this one right here. X plus y is less than 1 minus x. Y is less than -x plus 1. So let's see which of those lines goes at a +1. It'd be this blue line. It is dashed, it is going down, 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 and they did shade below. So this is actually probably a good choice, but we need to make sure by picking this one. So it's plus x. Y is less than x minus 4. So let's see if we can find that line. It did cross at a -4 and it went up and over, up and over. It was dashed and they did shade below. So that checked out. So our answer is C. Alright, now on number 9, which of the following points is a solution? So I need to be looking in this area right down here. So let me graph -2, +3. -2, +3 would be about here. So that doesn't work. Let's graph 2, 3. 2, 3 would be over here. That doesn't work. -2, -3. -2, -3 would be right here. So that point is in our solution set. Okay? Now down here, without graphing, can you determine the correct solution? So what this means is I want to basically plug in an x and plug in a y and see if it works out. This equation at bottom looks easier, so let me plug them into that problem first. So remember, this is your x coordinate and this is your y coordinate. So you're going to put y right here, -1 greater than 2 times x, so 2 times -4, minus 1. So now you just need to simplify and see if the answer is true. So -4 times 2 is -8. Bring everything down. I know -8 minus 1 is -9. So, is a -1 greater than a -9? It's true. Okay, when you've got negatives, the lesser of the negative is bigger, because think about being in debt. You'd rather owe me $1 than owe me $9. So since it worked in that problem, I need to make sure that this same ordered pair works in the top equation. So let me do that in red. So 3y, so 3 times -1 is less than -x, so -4 plus 4. So now I just need to do the math and see if that works out. You get -3 is less than, this becomes a +4 plus 4. So is -3 less than 8? Yes, that's true. So since this point worked in both of my equations, that is going to be our answer. Luckily, it was the first one. So if that answer was all the way down here, yes, you would have to check every single one of those and make sure it didn't work out. Okay? Thanks for watching the systems video.